Hi, good morning, everyone. This is Kanu Butani here, and today we will be seeing supervised learning and try to see what, when, where, why, how, and who uses the supervised learning. And we will also see one example along with the Python code. So, this is going to be a very interesting video for supervised learning. So, what is supervised learning? It is a machine learning technique which uses the labeled data sets to train the uh, algorithms, and it inputs are mapped to known outputs, and the goal is to predict or classify the output, and it learns from the samples and examples that are given to generate the patterns. So basically, it is like helping the user to classify or predict something. So this supervised learning really helps in classification and prediction mostly. So we will see how it is happening. So when it is used, when the historical data is with labels that exist, so labels is what one output is there. A column is there that is basically labeled as the output column, and the other labels are input columns. So we know the historical data, and in predictions, predictive modeling scenarios, when outcomes are measurable, and during classification and regression tasks, yes, we will see regression also, and when the accuracy and reliability are needed. So, the supervised learning also deals with accuracy and reliability, because even one um thing goes false positive and or false negative, that will not help. So the accuracy is very important, and reliability. So where it is applied in banking for fraud detection, in healthcare for disease diagnosis, in e-commerce for product recommendations, the recommendations that you see if you order a, say, a t-shirt, then based on your choices of t-shirts, it will recommend the different types of jeans and trousers, and in finance for credit scoring, and in voice and image recognition systems. Can why it is important? Because predictions improves the decision making, label data ensures accuracy, it reduces the human efforts in repetitive tasks, it scales to large databases, and it builds trust in AI applications. How does it work? It collects the labeled data set, input and output. It splits the data into training and testing sets. Train model using algorithm, SVMs, decision trees, etc. It evaluates with accuracy or error metrics, and deploy the trained model for real world use. So basically, it collects the data and it trains itself, and by splitting the data into testing and training data, and then it creates a model of training model based on different algorithms. And then who uses it? Data scientists, business for predictions, healthcare professionals for diagnosis support, financial analysts for risk scoring, and tech companies deploy them in apps and products. So the example is loan default prediction. So bank wants to predict loan default. Input X is income, employment status, credit history, and outputs Y are loan repaid, yes or no. So the model will be trained on past data, and it predicts if new application will default or repay. So the based on the inputs and outputs, based on the data that we have, we will train the model that who all people paid and who did not pay, yes or no. And then when the new applicant comes in, then we can immediately predict based on the inputs of income, his employment status, and credit history. We can immediately come to know that the new applicant who is there, will he default or will he repay? So that is what the loan default prediction we are doing. Example. So in this, the data set, if you see the income, these are 20,000, 50,000. Employment status is employed or unemployed. Credit score is what here. And then loan repaid is yes, no, yes, no, yes, no, yes, no. So the output is yes, no, loan repaid. Then comes training and testing data split. Training data 70% customers 1, 2, 3, 4, 5. Testing data 30% customers 6, 7, and 8. Features are X are income, employment status, credit score, and label is the loan repaid, yes or no. It is used for classification, loan and regression in this case. Then this is the Python code, that data preparation that you can put in to check how it will run in Python. So I will be putting the entire code in the description. So you will get all this entire code in the description, and then it will give you the output. Uh, at present, the model output example will be accuracy 100% because it's a small database. Predictions, the customer 6 will be no, customer 7 yes, customer 8 no.